Project and embedded systems. So table contents here are overview of the project, embedded language, embedded system and its components. What is a microcontroller? PIC controller. Goals of the project, software used, peripheral use, project demonstrations and conclusions. So overview of the project. Objective: simulate the core operation of a washing machine using embedded systems principles. Microcontroller used. PIC16F877A, chosen for its reliability, multiple I/O ports and ease of interfacing. Key functions stimulated: washing, rinsing, spinning, control via times, interrupts and user inputs. Automation focus: mimics real-life washing machine behavior, demonstrating time cycles and user control logic. Educational purpose: offers hand-on understanding of embedded system designs, peripheral interfacing and real-time system controls. So what's the outcome? A fully functional prototype that highlights the potential of microcontroller based home automating situations. Embedded language: 1. Speed, portability and hardware level control. C remains the dominant language in embedded systems development due to its unmatched execution speed, lightweight nature and ability to interact directly with the hardware. Unlike high-level languages, C offers low-level access to memory and system registers, allowing developers to write highly optimized code that runs efficiently on resources-constrained devices. Efficient use of data types and memory management. C allows precise controls over data types and memory allocations. Embedded developers can select the most efficient variable based on system requirements, optimizing memory uses and performance. Proper use of integers, floats and bit level operation is a crucial in embedded systems environment where every byte counts. 3. Pointers and directors hardware manipulation. One of C's most powerful features in embedded system is its use of pointers. Pointers allow direct manipulation of memory and hardware registers, facilitating precise control over I/O operations, timers, and peripheral devices. This capability is essential for writing low latency, real-time embedded software. 4. Structural control flow for real-time responsiveness. C provides robust control structures, loops, conditionals, and switch statements that are vital for handling real-time events. These constructs help create responsive programs that can make logical decisions based on sensor inputs, user actions, or interrupt signals. 5. Modular and scalable code through functional C programs modular programming through the use of functions, enabling developers to break down complex tasks into manageable, reusable blocks. This not only improves the code readability and debugging but also enhances the maintainability and scalability for future update. 6. Preprocessor directives for flexibility and portability. The C preprocessor supports macros, header files, and conditional complications, which help create flexible and adaptable code bases. Developers can tailor code to specific hardware platforms, reduce redundancy, and abstract hardware-specific logic, making the software more portable across different microcontrollers. Embedded systems. So definition, what is the definition here? A compact system combining hardware and software designed to perform a specific task efficiently within a board system. Key characteristics: first, the dedicated function; second, the high real-time operation; third, high reliability and low power consumption; 4. Often embedded in a larger device. Real-world examples: home appliances, smart TVs, microwaves, ovens, air conditioners; industrial automation, robots, PLCs, control systems; aerospace, flight navigation and control systems; healthcare, MRI machines, ECG monitors, heart rate sensors, wearable techs, and like smartwatches, fitness trackers, and smart glasses. Types of embedded systems. Here a flowchart of the given thing. We have discussed about types of embedded systems that are standalone or slave standalone embedded system, network embedded system, real-time embedded system, which is divided into 3 parts like hard real-time embedded system, firm real-time embedded system, soft real-time embedded system, and the 4th is mobile embedded system and hybrid. Embedded system and its components. Embedded system hardware components are divided into 6 categories: power supply, microcontroller, memory, timer or counter, communication ports, input or output. What is microcontroller? Definition: a self-contained programmable chip that combines CPU, memory and I/O interfaces for controlling embedded systems functions. First, takes inputs, example button presses, makes logical decisions. Third, produce outputs, example run a motor on it, updates a display. Why use PIC16F877A? First, there are certain reasons, because the first is 40-pin microcontroller with 5 I/O ports, portability, porta-porte, supports timers, interrupts, serial communication, and SPI. Third, operates the crystal oscillator, 4 to 40 MHz range, easy to program and high reliable and educational real-life projects. PIC microcontroller. To build this project, we are using a PIC16F877A microcontroller. Specification: it has 40 pins. It contains 5 I/O ports. The first are port A 6 pins, port B 8 pins, port C 8 pins, port D 8 pins, port E 3 pins. Supports serial communication via TX and RX pins. Also supports SPI protocols. Operates with a oscillator. Frequency range from 4 MHz to 40 MHz. Goals of the internship. Goals: stimulate a basic washing machine system using PIC16F877A microcontroller. Key functions: automate washing, rinsing, and spinning cycles through programmed logic. User interface: first, push button for user control, 16:2 LCD display, current mode, time, and status. Core features: first is accurate cycle timing using timer 2, real-time response with external internal interrupts. Third is smooth and efficient process flow using embedded C logic. Educational impact: demonstrate the practical use of microcontroller for real-time automation and embedded design system. Block diagram of the project. Washing machine stimulator. Here is a block diagram project you can see. The next slide is hardware requirements. We use PIC16F877A microcontroller, 16:2 CLCDs, push buttons for start-stop mode selection, fan for motor stimulation, crystal oscillator, typically 20 MHz, capacitor, resistors, breadboard, power supply 5 volt regulator. Software requirements: PIC SimLab, PIC Gen iOS, PIC16F877A MIC board. 2 is MP Lab XIDE X8 compiler. Peripheral used: LED, tactile switches as digital keypad, CLCD, timers, interrupts. LED, light emitting diode. A light emitting diode is a highly efficient semiconductor device that emits light when a suitable electric current passes through it. Unlike traditional bulbs, LED operates on the principle of electroluminescence, where the recombination of electron holes with the semiconductor material make them an essential component in modern electronic systems. Tactile switches as digital keyboard. A microcontroller based switches as fundamental input device, enabling the users to interface with the control the operation of the system. These switches, often tactile push buttons, are connected to specific digital input pins of the microcontroller, where a button is pressed and completes the circuit, pulling the pin voltage to a logic low to high level depending on the configuration which the microcontroller interprets and on state, and conversely, when the button is released, the circuit breaks and the interrupt turns to its default idle state, usually read as off. CLCD, character liquid crystal display. Purpose: used to display the status of washing machine, such as selecting mode, timer, countdown, water level, and pressure updates. Interface: connected in 4-bit mode and 8-bit mode using port. Commands used: clear display, cursor positioning, undetected display interrupts. User benefits: provides real-time feedback and improves user interface with the stimulator. Interrupts: purpose: enabling the real-time response to events without continuous polling. Key events: handles button press, timed events. Interrupts types: use time to interrupts. External interrupts: INT10, INT0, detects user inputs for control commands. Benefits: improves efficiency by executing tasks only one time needed. Supports multitasking and real-time interaction, reduce CPU overhead and power consumption. Timers: purpose: used to generate accurate time delays and control cycle regulations. Example: wash time, rinse time, spin time. Timer: used timer 2 with a pre-scaler and post-scaler mode, timer or counter mode depending on internal clock or external input. User benefit: allows stimulation of real-time washing duration without blocking program flow. Project demonstration. Conclusion: the project successfully demonstrated the design and simulation of automated washing machine system using a PIC16F877A microcontroller, shows the practical application of embedded system principles by effectively integrating key peripherals including timer to interrupts, tactical push buttons, and a 16:2 LED character structures. The system automates essential functions such as washing, rinsing, and spinning, replicating the behavior of a real-time application within a controlled and stimulating environment. The implementation of highlight a capability of microcontrollers to manage real-time processes, respond dynamically to user interface, and execute execute the time-bound tasks with precision. The project served as a hands-on exploration of embedded C programming, peripheral interfacing, interrupt-driven control, and system timing, key pillars of embedded development. End of the project.